Yes, so let's move to the next problem, and it says for an LTA system the impulse response is given by h of t equal to sine 4 of t minus 1 by pi of t minus 1. So we have to find the output of the system for the given input. Okay, so let us write down what is given here. So this is an LTA system, so definitely we have to draw the block diagram so that we can understand this. Yes, so this is the LTA system. I'll put a little bit up. Okay, so input is x1 of t, and this is an LTA system with impulse response h of t, and we are asked to find out the output y of t. Let me call it as y1 of t. Okay, so definitely what is y1 of t equal to, that we'll write down here. Y1 of t would be equal to x1 of t convolved with h of t. Okay, but what is x1 of t? X1 of t is nothing but sine 4 times t plus 1 divided by pi t convolved with sine h of t is sine 4 of t minus 1 divided by pi times t minus 1. Here you get pi times t plus 1. Okay, so this can be written as, if you are aware of second chapter, we can write this as sine 4t by pi t convolved with delta of t plus 1, and this is convolved with sine 4t by pi t convolved with delta of t minus 1. Okay, right. So because the convolution operation satisfies commutative property and associative property, so we can jumble the terms in this convolution. Okay, yes. So but if you look at this carefully, we can, what will be the result of convolution of these two guys here? That fellow will give us delta of t. Okay, yes. So finally we get this to be equal to sine 4t divided by pi t convolved with sine 4t divided by pi t, and this fellow convolved with delta of t. So this finally would give us sine 4t by pi t convolved with sine 4t by pi t. But if you remember our notes, this is looking like sine wt by pi t convolved with sine wt by pi t. So that should give us again sine wt by pi t. So that would be the output of the LTI system. Okay, yes, same problem. The question is we have to find the output of the system if the input is this one. So let us again draw the block diagram. Question is, if you give x2 of t as the input to the LTI system, okay, and let the output be y2 of t, and what is the impulse response of this system? Let us sorry, it is same LTA system, so impulse response would be same h of t. So what is the relation between these three guys? We see that y2 of t is equal to x2 of t convolved with h of t. Okay, so but what is x2 of t here? It is sine 2t divided by pi t whole square, and this fellow is convolved with h of t. We know that to be sine 4t minus 1 by pi times t minus 1. Okay, so as usual, let us write down this to be sine 2t by pi t whole square. This fellow is convolved with sine 4t by pi t convolved with delta of t minus 1. So first we will try to evaluate this convolution, and then finally we convolve with delta of t minus 1. Okay, so let us write down individually what are the corresponding Fourier transforms. Sine 2t by pi t whole square can be written as what? Sine 2t by uh, sine 2t by pi t. This fellow is multiplied with again sine 2t by pi t. Okay, so this is multiplication in which domain? Multiplication in time domain. That should correspond to what in frequency domain? That should correspond to convolution in frequency domain. So convolution of which functions here? Fourier transform of sine 2t by pi t, which would be a rectangle from -2 to +2 with amplitude 1 convolved with same rectangle from -2 to +2 with amplitude 1. Okay, but we know that convolution of two rectangles of same width will give you what as the Fourier transform? You get a triangular function. Okay, you get a triangular function from where to where? So from -4 to +4. So what would be the amplitude here? Amplitude of the Fourier transform would be 2a1 is 1, a2 is 1, 2a1, a2, t is 2 again. So you'll get 4. 4 divided by 2 pi would be 2 by pi. Okay, 4 divided by 2 pi would be 2 by pi. So what is that we have got finally? Sine 2t divided by pi t whole square. We'll have this as the Fourier transform. Okay, right. So next let us take the another signal which we have, right? So sine 4t divided by pi t. So this fellow will have what as Fourier transform? This fellow will have a rectangular function from -4 to +4 with amplitude 1. Okay, so if you look at what we are evaluating this convolution. Which one? Sine 2t by pi t whole square convolved with sine 4t by pi t. So we got Fourier transform of sine 2t by pi t whole square, and now we got Fourier transform of sine 4t by pi t. Next, what is that we have to do? We have to convolve in time domain. So convolution in time domain, correct, is same as multiplication in frequency domain. So if you multiply the corresponding functions, okay, what do you get? Okay, I put equal to here, so would give you what shape you get here? This is a rectangular function of amplitude 1. So 1 multiplied with triangle, both are of same width, and hence there won't be any change. So 1 multiplied with this triangle would be again a same triangle. From where to where? From -4 to +4 with amplitude 2 by pi. So this triangle is not going to change, and hence what happens in time domain? So this triangle will have this as the Fourier transform. So this should be equal to sine 2t divided by pi t whole square. So that would be the convolution of the term inside the square bracket, correct? So inside the square bracket we have a convolution. Okay, so we are done with this convolution operation. So we got what as the answer? Sine 2t by pi t whole square as the answer, and now that whole function is convolved with delta of t minus 1. So that we call it as y2 of t. Okay, so what happens to y2 of t finally? So y2 of t would be equal to sine 2t divided by pi t whole square. This is a term inside the square bracket convolved with delta of t minus 1. So this simplifies to how much here? This would be equal to any function convolved with delta of t minus 1 means what? You have to shift the function. So means what? You have to replace t with t minus 1. So you will get sine 2 of t minus 1 divided by pi times t minus 1 whole square. So that would be the final output of the LTI system, for which input sine 2t by pi t whole square.